Welcome to lesson 1.7. In this lesson, we are going to solve systems of equations using a matrix, using matrices. Might sound weird, it kind of is, and we'll kind of work through it here. One thing of note is there's no way I would solve what we're about to in example 1 using a matrix. It's obviously way more efficient to solve a 2x2 matrix with elimination or substitution. With this one, probably elimination. However, solving a 3x3 using matrices is way more efficient. So we're going to learn how to do it with a 2x2 first. So this is just a means to an end. All right, so let's get through it here. All right, so the first thing we do is we turn the equations into a matrix like we learned last lesson. And you don't need to write out the equations every time, but for this example, they're kind of showing you what's actually going on. So what they did is they multiplied the first row by 2 and the second row by 3 in an effort to try to get the x's to 0. Because the ultimate goal here is to turn this matrix into the 1, 0, 0, 1 matrix. And then the answers will be on the side here. Okay, so then the first thing they did was they got the 0 in the first spot by then subtracting the first line by the second line. Okay, and then they reverted that line back to the original there. Then, in order to get this spot to be 1, they divided everything in the first line by negative 19. So essentially, you've got the first matrix in the right spot. Sorry, the first row of the matrix in the right spot. You've got 0 and 1. Now we're going to do the same thing for the second row. All right, they multiply the first row by negative 5. And it's okay that, we got this the way where we wanted to, and now we're doing an operation. We can just revert back to that whenever we want. So multiply the first row of the matrix by negative 5 in order to get that to cancel out. All right, then we're going to add the two rows together to create a new row. Now we've got the 0 in the spot that we wanted. Now we're just going to divide that row by 2, and you get 1, 0, 7. Then they just flip it so that way the row with 1 for x is first, and the row with 1 for y is second. What that means is that x equals 7 and y equals negative 2. So that's your solution. And you can simply check it by just taking your solution and substituting it back into the original equations. Since it checks out, you have your solution, 7, negative 2. Okay. Let's try this on your own. I'll work it out, you pause it, you try to work it out yourself, and then let's see if we match up. Okay. So the first thing I'm going to do is convert the system of equations into a matrix. So 2, negative 5, 11, 4, 3, 9. And our goal is just to get, again, it to go 1, 0, 0, 1, and then whatever's over here will be our solutions. So the first thing I would do, I think, is try to get this to be 0. So I'm going to multiply the first line by 3 and the second line by 5. That'll create opposites there that we can then add together and get a 0 in that spot. So I'm just going to rewrite it up here. We've got 6, negative 15, and then 33, and then 20, 15, and 45. Okay. When we add those two lines together to create a new line, we get 26, 0, and then 78. All right, I'm going to revert back to the 4, 3, 9 down here. Then I'm going to take that first line and just divide that by 26. I guess it makes sense if I put the divide before it, right? So 26 divided by 26 is 1. That was our goal, try to get 1 in that spot. 0, and then 78 divided by 26 is 3. Kind of worked out nice. All right, and then I still have 4, 3, 9 here. All right, then I want to try to get a 0 in this spot. So I'm going to multiply that first line by -4. And then I can revert back to the 1, 0, 3, because this means x equals 3. All right, so I have half my answer at this point. And I can revert back to that when I need to. So now I've got -4, 0, -12. And then this one's still 4, 3, 9. All right, when I add those together, I'll try to squeeze it in up here. When I add those together, I get 0, 3, -3. All right. And now I can also, again, revert back to the 1, 0, 3. And then if I divide that first row by 3, I get 0, 1, -1. All right, and I still have the 1, 0, 3. So then if I rewrite the matrix, just flipping the rows, I have 1, 0, 3, 0, 1, -1. And what that means is that x equals 3 and y equals -1. Again, you could have got this way faster if you just substituted by or solved by elimination, but we're practicing how to do it this way because this way is going to be faster when we do a 3 by 3 in the next example. So now let's try the second one. So maybe you pause it now. You didn't get the first one, pause it now, and then try the second one. So same thing. I'm just going to convert it into the matrix to start. I want to try to get 0 in that spot there. So I'm just going to multiply the first equation by 2. That'll create a -8 there, and when I add them together, I'll get the 0 that I want. So I've got 6, -8, -36. And then that's still -4, 8, 32. I didn't have to touch the second row. All right, now my new first row is going to be adding these two rows together. So 6 plus -4 is 2. -8 plus 8 is 0. -36 plus 32 is -4. I'm going to revert back. Well, I'm not reverting back because I didn't actually touch that. So -4, 8, and then 32. The first row, I'm going to divide by 2. And that's going to give me 1, 0, -2. And that row we haven't touched yet. So that does mean that x equals -2 is one of our solutions. Well, half of our solution, I guess. So now we got to work with the second row. What I'm going to do is multiply that top row by 4. So then I want to try to get this to be 0. So I'm going to multiply the top row by 4, and I'm going to get 4, 0, -8. You get -4, 8, 32. Haven't touched it yet. I guess I should be putting this line here, but whatever. Now I'm going to add those equations together. and I get my first line is going to be them added together. So 0, 8, 24. And I'm just going to revert back to this line for this part of the matrix. 1, 0, -2. And then in order to finish it off, I need to get that to be a 1. So I'm going to divide by 8. All right, I'm actually going to make that the second row because I'm going to flip it anyway. So my first row is going to be that 1, 0, -2. And then dividing by 8 on this row is going to be my new second row here. So I'm going to get 0, 1, 3. So that means x equals -2, y equals 3. All right, so my ordered pair solution, that would be -2, 3. Okay, so again, no way, I'm going to say this again, like I understand the frustration if you think like, why am I doing this? There's no way this is faster than what I already know how to do, and that's true for a 2 by 2. The value in what we just practiced, what we just learned, or whatever, is to do this with a 3 by 3 matrix. And that's what we're going to do in the next example. Okay, so let's give that a try.